9.2 is adding and subtracting rational expressions. 9.1 was multiplying and dividing. People don't like chapter 9 because you take all the fraction stuff you used to do and then start throwing variables and binomials and trinomials into it. But just think about your basic fraction things. If I'm going to take 3/4 and 5/7 and add them, I need to find the lowest common denominator. That's the whole game with adding and subtracting fractions, find the lowest common denominator. Well, in this case, it's 28. So multiply this by 7/7, and this by 4/4, and get 21/28 plus 20/28, which then becomes 41/28. And I would just leave it like that. I don't need to make that a mixed number. Improper fractions are fine. We're going to do the same thing with these problems. Find the lowest common denominator. In this case, it's x minus 1 times x plus 3. I mean, this expression over here, this fraction needs an x plus 3 term. And this fraction needs an x minus 1 term. So I'm going to multiply this by x plus 3 over x plus 3. And multiply this by x minus 1 over x minus 1, just like I did over in the green problem. And I end up with 2x plus 6 over x plus 3x minus 1 plus 5x minus 5 over x plus 3x minus 1. I can add up the top and the bottom stays the same, so I have 7x plus 1 over x plus 3x minus 1. If this could simplify it all, I would simplify it. Those 1's can't cancel, the x's can't cancel. There's no need for me to distribute or FOIL the bottom. I'll just keep this in the form that it's in, and remember, x cannot be -3, and x cannot be 1. Because those are the two things that would make me divide by 0. And on the right, if you want to pause and take a moment and figure what the lowest common denominator is, you sure can. And multiply by x plus 6 over x plus 6, and x minus 2 over x minus 2, and I get 10x minus 20 over x minus 2, x minus 6, minus 4x plus 24 over x minus 2, x minus 6. Now you have to be really, really careful. It's plus 6. Really careful about that negative. I'm really distributing the negative to everything on top, and this is what people tend to forget. This tends to be where mistakes happen. I'm going to do 10x minus 4x, which is 6x, but also 20 minus 24, which is -4. It becomes 6x minus 4 over x minus 2, x minus 6. So that should be a plus. X plus 6. Now I can check to see if this can factor at all on top. Like on top, I can pull out a 2 just to see if anything else can cancel. If I pull out a 2, I get 3x minus 2. But that's not going to cancel with anything anyplace else. So I didn't really need to do this final step. This step here is really an okay place to end because nothing can cancel. Although this is also just fine. Factor forms are really nice. I know that x cannot be 2 and x cannot be -6. It doesn't matter about the top. I don't care if the top ever equals 0. That doesn't change anything. I just worry about the bottom equaling 0 because I'm not allowed to divide by 0. Well, now we don't have binomials so much as just lots and lots of terms. I look at each individual piece. I check the coefficients in each individual variable, the x's, or in this case the y's, and the first expression has no y's. Well, to get a lowest common denominator, I want to see 2 goes into 8, so I know that I at least need everything to have an 8. X to the third, well, x to the first goes into x to the third, so I need to have at least an x to the third. And there's no y's here, no y to second here, so I need to have a y to second here. I need everything, I need this to be my lowest common denominator. I'm basically checking, what's the first thing that both 2 and 8 go into, and it's 8? What's the first thing that both x to the third and x go into, and it's x to the third? And what's the first thing that y squared and 1, basically, there's no y's there, and y squared and 1 is y squared. So the left side needs a 4 and a y squared. So do that on top and on bottom. I'm always multiplying by 1. The right side just needs an x squared. And that gives me 12y to the third over 8x to the third y squared plus 5x squared z over 8x to the third y squared. Now that I've got that common denominator, I'm going to add up the top. So it's 12y to the third plus 5x squared z over 8x to the third y squared. If you can start doing this faster and in fewer steps, good for you. X cannot be 0, y cannot be 0. So on the right problem, take a moment, pause it, and see if you can figure out what the lowest common denominator is. The lowest common denominator is going to be 12xy to the third. 12 is the first number that both 4 and 6 go into. This has a y to the third, so this will need a y to the third, and this will need an x over here. So it's 12xy to the third. So now I think, how do I make that happen? How do I get this to become 12xy to the third? Well, I multiply the top and the bottom by 3 and by x. Over here, I multiply by 2y squared. It's 21x squared minus 10y squared over 12xy to the third. The bottom is always just going to be your denominator, which is really nice. If anything could simplify it all, I would try to simplify it, but nothing can, so that's my solution. Okay, combining like terms, getting common denominators, playing with fractions that get kind of messy when they start. This one now has binomials and addition subtraction. So I'm going to start by factoring everything. I can't try and find the lowest common denominator without having factored first. So in the bottom here I can pull out a 6. And this one I can start by pulling out a 2 and just seeing if that gets any easier. Now, I don't think we factored any where the a value wasn't 1 last time. Here the a value isn't 1, and I can't pull out that a. So I'm going to try and factor that by guess and check or by grouping. And if you want to reteach yourself either of those methods, there's videos online for that. This is going to be 2, I have 2x and x. One of them is positive and one of it is negative. In fact, they're both negative, and I'm going to do minus 1, minus 3. Okay, now I'm all the way factored, and this is just going to help me find my LCD. All that work is just to help me find the LCD. They both have an x minus 3 term, so I know that the x minus 3 is going to be part of my LCD. This one has a 6, and this one has a 2. Well, the lowest common factor, multiple of 2 and 6, is 6, so they definitely need a 6. And then they're all going to need at least a 2x minus 1 as well. Every factor that appears in one of the fraction pieces has to appear in all of them. You can't leave any factors behind, so you don't really have a lowest common denominator. You're missing stuff. So now I start asking the question, what does each side need to look like this? Well, this side needs a 2x minus 1. This side needs 3. And it's going to give me 10x minus 5. Scroll down now. 10x minus 5 minus 3x plus 3. Because remember, I'm distributing this negative. So there's x times 3 is minus 3x. And then negative 1 times 3 is negative 3, but then the negative sign changes it. So I have this over my LCD, which was 6x minus 3, 2x minus 1. Keep simplifying. 10x minus 3x is 7x. Negative 5 plus 3 is negative 2. And I'm simplified, x cannot be 1/2, and x cannot be 3. So you can pause and look that over a little bit if you'd like to. Here's as much as I can fit on one screen right now. If you also want to try the problem on the right, I think that's worthwhile. I say that a lot. I think it's worthwhile. I bet I do. x minus 1 over x minus 3, x plus 2, minus 4 over 5 times x plus 2. So my LCD here is going to be 5 x minus 3, x plus 2. Which means that this needs an x minus 3 over on this side. This needs a 5. So I get 5x minus 5 minus 4x plus 12 over 5 times x minus 3 times x plus 2. 5x minus 4x is x, negative 5 plus 12 is 7. So x cannot be 3 or negative 2. Find the lowest common denominator, get everything to have that denominator, combine your numerator, which is your top, and then simplify as far as you can. These will be the last ones we do. I think these are especially scary looking because you have a number added to a fraction inside a fraction with another number added to a fraction inside a fraction beneath it. The key is to simplify the top and the bottom into big fractions as opposed to little fractions. So I'm going to work with these in halves. I'm basically going to start by working with this half up here. And I know they have a common denominator of x. I'm going to multiply this by x over x. And this gives me x plus 1. Well, I'll write the step in between. Gives me x over x plus 1 over x. Which really becomes x plus 1 over x. That's the top. Now the bottom needs a y. So it becomes y over y minus x over y. I'm sorry, I'm writing this kind of weird. I'm not used to showing the step in between. Which is really y minus x over y. So this basically turns into the fraction x plus 1 over x over y minus x over y. And the good thing is I've gotten rid of having these little separate pieces. Now I at least have separate fractions, or whole entire fractions here. Well, this is the same division of fractions as multiplication by the reciprocal. X plus 1 over x times y over y minus x. Take the second fraction and I flip it over. Nothing here can cancel, so I'm just going to write this as xy plus y. Actually, I'll just leave it back to form. I think it's nicer in back to form. And now it's kind of tough to think about what x and y can't be. X can't be 0, and y can't be x. Because if y and x equal each other, y minus x is 0. And we're not allowed to divide by 0, so y can't equal x. If x is 12, y can't be 12, and if x is 20, y can't be 20. We're going to try this one on the right side on your own, you sure can. But I'm going to go for it. These need to have a common denominator, so multiply by c over c and d over d, which gives me c squared minus d squared over cd. The bottom is a c over c, so it gives me d plus 2c over c. And this fraction. Well, if I flip and multiply, I have c squared minus d squared over cd times c over d plus 2c. There's a little bit of canceling that can happen here, not a lot. But this c multiplied with this c, those can cancel. So I end up with just c squared minus d squared over d times d plus 2c. And again, factor form is really nice. D cannot equal 0. And then if I take d plus 2c and set it equal to 0, I'll know what c can't be. I don't want this to happen, which means that 2c shouldn't be negative d, which means that c cannot be negative d over 2. C cannot be half of d divided by 2. If you don't get this stuff, that's not the end of the world. What d and c can't be isn't what matters the most, but it's at least good to see it. And that takes care of this section. Have a wonderful day.